Okay, in this video, we're going to discuss the Milky Way galaxy, how it was potentially formed according to Anthko's theory of time, and when it was formed, and why it has the shape, the raindrop shape it has. I think let's start with why it has the raindrop shape it has. And as discussed in the previous video, that is due to the flow of time around it and the highly concentrated viscous time solution that saturates the Milky Way galaxy. That's why it has the shape. Now, why does it have a highly viscous time solution versus just outside of the galaxy having a fairly non-viscous, non-concentrated time solution? That could only be possible, according to Anthko's theory of time, if the Milky Way was actually inside of the black hole before it supernovaed and created what we now know as the universe, or what we understand to be now the universe. And some of you might immediately be asking, well, if the Milky Way was inside of the Big Bang when it happened, how could it have survived? And a couple videos back, we actually talked about how the universe was created according to Anthko's theory of time, how black holes are a super viscous, super concentrated solution of time that's so concentrated that time nearly stands still, which indicates that it's nearly a solid mass, and that is the black hole. And in that super viscous solution, temporal quanta or time particles act upon other temporal quanta or time particles, making them age and eventually, for lack of better terminology, die, which actually reduces the viscosity in those areas, much similar to how air bubbles are formed in the bottom of a pot of boiling water. Water vapor is formed and it has significantly lower viscosity and density than the surrounding aqueous solution. So similar thing, but only the catalyst is not heat, it's time acting on time inside of a black hole. So when one of those lower density pockets of viscous time was created inside the black hole, it permits things to age slower and move more quickly than in the surrounding highly dense time material of a black hole, which permits exotic particles and less exotic particles to move more freely, live much longer half-lives and lives, and interact with each other more readily and frequently. Now, the exact nature by which the Milky Way may have been created is not defined by Anthko's theory of time, but because of the shape of the Milky Way and the way it's positioned according to Anthko's theory of time versus the flow of time within the universe, this suggests that it would have been in one of these lower viscosity pockets, and it would have been most likely near the edge of the black hole, but inside of the black hole. And when the supernova happened, the accretion disk would have been spread out horizontally to or in a very flat manner across the known universe, and those things inside of the black hole would have been spread out in all directions in a spherical pattern throughout the known universe. And of course, the Milky Way potentially being one of those things. And that indicates that the Milky Way may not be on that flat plane or have been in the accretion disk because the direction of the main plane of the Milky Way is perpendicular to the flow of time throughout the universe and not parallel. Whereas the accretion disk, all things in the accretion disk potentially would be parallel to that time flow. It's also notable to mention that the higher viscosity of time or potential viscosity of time within the Milky Way and our solar system would indicate that the Milky Way was within the black hole in one of those less viscous solutions, because when the supernova happened, according to Anthko's theory of time, those things in the accretion disk would have had much lower viscosities, time viscosities, and time would have been much similar to the surrounding universe's flow of time. Since the viscosity within the Milky Way is higher, this indicates that it retained some of the viscosity prior to the supernova, and also indicates that time flows much slower within the Milky Way. So to summarize very quickly, the Milky Way galaxy in which we reside, according to Anthko's theory of time, has a higher viscosity than the surrounding universe of time. The solution is much more concentrated with temporal quanta, and the galaxy is perpendicular to the flow of time in the universe that surrounds it, which provided its shape. And because of the perpendicular nature and the high viscosity rate of time within the Milky Way galaxy, this indicates that the Milky Way galaxy formed within the black hole prior to the Big Bang, and potentially could have been one of the catalysts that created the Big Bang. Some very exotic theory in there that is supported by a fundamental theory in physics, but something interesting to think about as we move forward, and potentially thinking that, hey, the Earth could have been created prior to the Big Bang, and that's supported by science, and the fact that even though it was created prior to the Big Bang, it's much younger relative to the surrounding universe, is really an odd paradox. I think that's all for now.